to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze the gate valve for its static structural analysis. We will start by double-clicking on the static structural module. We will first go to engineering data and double-click. Engineering data sources, general materials. Here I'll choose stainless steel as one of the material. Then we'll go back to engineering data sources and we'll add two more materials. One of them is brass. We'll give the value of density 8490 kg per meter cube. We will click on brass once again, then we'll double click on isotropic elasticity. We will give the value of Young's modulus, which is 97 gigapascal. So I first change the unit, then I'll give the value as 97. Value of Poisson's ratio is 0.31. If you click on brass, you still have these values which can be provided. So you can give the value of ultimate yield strength. You can give the value of tensile yield strength and tensile ultimate strength. So we'll give the value of yield strength first. It is 310 megapascal. Also, we will give the value of ultimate tensile strength, which is 469 in megapascal. So once this is done, we will go to the next material, which is bronze. We will give the same properties for bronze as well. We will start with density. This value is 8410. I'll click on bronze once again and double click on isotropic elasticity. The value of Young's modulus in gigapascal is 138. Poisson's ratio is 0.42. We will click on bronze once again and double click on tensile yield strength, which is 800 megapascal. I'll double click on tensile ultimate strength. This is 1010 megapascal. So change the unit first, 1010. So we have created three material now. We'll go to project and update project. Next, I'll go to geometry, right click, and I'll import the geometry. I'll now go to model and double click. We'll first go to geometry and click on this plus sign. We'll select all the parts. We'll change the material first to stainless steel. Next, we'll go to mesh and update the default size of the mesh. Next, we'll go to static structural A5. We will insert fixed support first on these two sides. We need to choose face option. Click here and click this one. You can press the control button, hold it such that you are able to click both of them. Then press apply. Then right click again and insert pressure. When the fluid will flow past this valve, pressure will be exerted on these internal surfaces. So you have to select all the internal surfaces. Once this is done, click on apply. Next, we will give this value of pressure, which is say 10 megapascal. Next, I will insert moment at this end, because when you use a gate valve, you use the turning action, which is torque or moment as you call it, on this gate valve to keep it open or closed. So I will right click here and insert moment. Now it is exerted on this surface internally. So I am going to select this part. Now I want to see if this entire rod inside has been selected. So I just go to geometry here. I'll hide this gland nut for some time. So I'll just hide this body. Now if I hide, I can see that this is not the part that I want. I want this as well. So I select this, as you can see. So I've selected. Then I'll go to moment. I'll apply the geometry selection, and from geometry here I'll unhide this body, or I'll show this gland nut once again. Now I'll go to moment. I have to give the value, so I'll just change this to component. Along the y-axis I will give the value as, say, minus 200 Newton mm. You can see here this is causing a turning effect over here. Then I'll go to solution, right click, insert deformation total. If you want, you can also see the deformation directional. Now which direction you want to see? It is the x-axis. Then I also want to see the strain equivalent and the stress equivalent. If you want, you can see the safety factor of this body. So you can select stress tool, go to solution and solve. We'll first select total deformation. You can see on this body. Value is 0.0021 mm. You can animate and check this result. Now what you see here is an exaggerated version because the deformation is quite low. Then we'll go to directional deformation along the x-axis. You can see the value is 0.00055 mm maximum. You can see the effect. We'll see the strain, it is 0.00049. Again, very low value. Stress is 78.44 megapascal, which is generated by this body when you use stainless steel as the material. And the safety factor, as you can see, it is mostly in this range of 10 to 15. That's why it is blue color. In some zone over here where you can see this green color, this range will be from 5 to 10. If you want, click on probe and you can just move the probe over this zone. So you can see it is between 5 to 10. So the body is completely safe. You don't have to worry about that. Under this value of pressure and moment. Under this value of pressure and moment, just click on probe once again. The option disappears. Now we are done with stainless steel. So we will go to geometry and select all the parts again. Change the material to brass. And solve once again. First we'll go to total deformation. You can see maximum value is 0.0042 mm. Directional deformation along x-axis maximum is 0.0011 mm. Strain is 0.00097. Stress is 78.441 megapascal. And the safety factor, which is more important, you can see here, it is mostly blue. In most of the cases, it will lie between this zone of 5 to 10. But in some case, it is possible that it will lie between 3.9 and 5 somewhere. You want to see where it is minimum and maximum, you can see here. Maximum is blue, 15. Minimum is somewhere here, as you can turn and see. It is this color over here, minimum. So you can click on max min once again, it will disappear. Now once this is done, we will see for the last material that we have used, which is bronze. So I'll select all these parts once again, change the material to bronze, go to solution and solve once again. For bronze, as the material for gate valve, the maximum deformation is 0.0029 mm. Directional deformation is 0.00081. Strain is 0.00067. Stress is 80.663 megapascal. The stress is a little more as compared to the other two materials, which is the resistance to the pressure being applied here. And the safety factor, you can see this is the safest. This is showing the range from 9.9 to 15. And in most of the cases, it was showing lower values. So if you have to use, you should go for bronze as the material for gate valve under this kind of condition, pressure or moment, such that your body is safer. If you want to cut down on the cost, you can go for any other material. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.